नमस्कार दोस्तों, मैं राहुल आपका स्टेम ट्रेनर स्वागत करता हूं मेरे इस चैनल स्टेम विद राहुल पर। लास्ट क्लास में हम लोगों ने मैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट को स्टार्ट किया था, जिसमें हम लोगों ने पढ़ा था मैग्नेट। ओके, फिर हम लोग पढ़े थे मैग्नेटिक फील्ड, मैग्नेटिक फील्ड एंड स्ट्रेंथ के बारे में। ठीक है, फिर हम लोगों ने पढ़ा था इलेक्ट्रोमैग्नेट के बारे में and and we have discussed why it is so popular, why it is so important and popular. Okay, उसके बाद हम लोगों ने पढ़ा था फोर्स, सॉरी, उसके बाद हम लोगों ने पढ़ा था करंट इन अ स्ट्रेट वायर, और इसके बाद इसमें हम लोगों ने जाना था डायरेक्शन ऑफ मैग्नेटिक फील्ड with the help of right hand thumb rule. ओके, राइट हैंड थंब रूल। आज हम लोग आगे बढ़ने वाले हैं। तो आज हम लोग क्या पढ़ेंगे? तो आज हम लोग पढ़ने वाले हैं करंट इन सर्कुलर वायर एंड डायरेक्शन ऑफ मैग्नेटिक फील्ड। उसके बाद हम लोग पढ़ने वाले हैं सोलेनॉइड। तीसरा हम लोग पढ़ने वाले हैं फोर्स इन अ करंट कैरिंग कंडक्टर। ओके, तो ये चार चीज हम लोग पढ़ेंगे। इसी के साथ हम लोग इसके अंदर क्या पढ़ेंगे? इसके अंदर हम लोग पढ़ेंगे फ्लेमिंग लेफ्ट हैंड रूल। ओके, तो चलिए स्टार्ट करते हैं आज का वीडियो। तो सबसे पहले आया करंट इन सर्कुलर वायर। ओके, करंट इन सर्कुलर वायर। तो ये मेरा एक सर्कुलर वायर है, ठीक है, और इसको मैं एक सेटअप पे रख दिया, डिजाइन कर दिया हूँ। ओके, एक सेटअप पे मैंने डिजाइन कर दिया है, सेटअप किया है, ठीक है, और इसके अंदर से फिर हमारा कनेक्ट होके हमारा बैटरी से कनेक्टेड है, ठीक है ना। जब हम लोग इसको कनेक्ट करेंगे तो क्या होगा? करंट विल स्टार्ट फ्लोइंग। Now, when the current will start flowing, it will flow in this direction, in circular direction, correct? Now, it is flowing in circular direction. Okay, so it will produce some magnetic field over here and it will produce a magnetic field over here. Okay, now यहाँ पे जो magnetic field create करेगा, इसका क्या direction होगा? Using right hand thumb rule, if current is going upward, so it will be in this direction. That means anti-clockwise. And here the current is going downward, so the direction of magnetic field is in clockwise direction. Okay, so here and here we have different orientation of magnetic field. Okay, here it is in anti-clockwise, here it is in anti-clockwise, and here it is in clockwise. Okay, so if we'll place iron nails of magnetic fillings here, what will happen? It will make some orientation in anti-clockwise, and it will make an orientation in clockwise direction. Okay. Now, so this is our current carrying in circular wire. Okay. Now, one more thing here to understand is what is the direction of magnetic field. So here it is in anti-clockwise, here it is in clockwise, but we can't say, right, we can't say ki, it is north pole or it is south pole, or which where it is north pole or south pole. So that is given with the help of clock face rule. Okay, clock face rule. Now, clock means it can be anti-clockwise or clockwise. Face means either this direction of wire or opposite direction of wire. Means if I will take the wire, so I can see from this side. Suppose this is my wire, okay, circular wire. So I can see it from here, or I can see it from here. Okay, correct. So that is my face. Okay. Now, how it will be forming? So suppose if the current is flowing in clockwise direction, if the current is flowing in clockwise direction, so that phase will be south pole. So see, it is making a it is making a clockwise direction. It is making a clockwise direction. And so if the current is flowing in clockwise direction, sorry, wait, if the current is flowing in clockwise, then that phase will be south pole. Okay, so if it this part is south pole, if I'm looking from here, it is south pole. So from if I will look it from here, it will be north pole. How? Let's see. So when we'll see from opposite side, it will appear in this way. Sorry, it will appear in this way. It will be appear in this way. Okay, so it will appear in this way. Okay, so the direction of that phase will be north pole. Okay, if I have reversed this, if I will look it from this side, so it will be anti-clockwise direction. So in anti-clockwise direction, if the current is flowing in anti-clockwise direction, that phase will be my north pole. Okay, north pole. You can easily understand this. You can easily remember this. How? See. So if we have it can be two the current can flow in two direction. Okay, now if it is flowing in clockwise, so it is flowing in clockwise. Okay, so it is south. And if it is flowing in anti-clockwise, if it is flowing in, wait here, anti-clockwise, so see, it is in anti-clockwise. Okay, or anti-clockwise, this one is my anti-clockwise. Okay, if it is clockwise, it is, if it is in clockwise, so it will be north pole, south pole, south pole, and this is in north pole. Okay, now, so this was all about current in a current in a circular wire. Okay, now current in a circular wire depends on certain characteristics, have certain characteristics. Okay, first is, So its magnetic field will depends on many factors. Okay, first is radius, radius of circular wire. If radius will be more, the strength will be less. Okay, if radius will be less, strength will be more. Why? So more the radius, what will happen? There will be the strength will be reduced. Just see in this way. So if I have, this is my magnetic field of this magnet. So if I will keep on increasing the field, what will happen? Here the magnetism is less. Here the magnetic strength is more. So that similarly in circular wire also, more the radius, lesser the magnetic field strength. Okay. Now next we are going to understand about solenoid. Okay, solenoid. So solenoid is nothing but it is circular wire with many turn. Okay, it is circular wire with many turn. Okay, now this is connected with a battery. This is connected with a battery. Okay, so if I will close the circuit, it will flow in this direction. So it will flow in this direction. So when I will look it from this side, just look it from this side, the direction of flow of current is in clockwise, clockwise. And when you will look it from here, you will find the direction of current is anti-clockwise, clockwise. Okay, so here this part of solenoid became south pole using clock face rule, and this part became north pole. Any doubt? Okay, understood? Now, so this is my solenoid. Solenoid means having many turns. Okay, solenoid is a coil with many circular turns of insulated copper wrapped closely in the shape of cylinder. Okay, now next is its strength. Magnetic field strength of solenoid depends on many factors again. First is number of turns. Okay, second is radius. Okay, these are the two factors on which a strength of magnetic field depends. So in number of turn, if it will increase, strength of magnetic field or magnetism will increase. More the number of turn, more the magnetic field strength, magnetism. Okay, if radius will increase, magnetic field strength will decrease. Okay, any doubt? Now third thing that we have not discussed, that is power source. If I will increase the amount of power source, if it is increased, strength of magnetic field also increases. So here only this one is the factor where if the radius increases, magnetic field decreases. Rest other two cases, it is if the magnetic field increases, strength if the if the number of turn or power source voltage increases, magnetic field increases. Okay, Understood? So this is all about solenoid. Now from solenoid, to increase the strength, what we do is, in solenoid, to increase the strength with more factor, what we do, we increase a magnetic core here, or iron core. Okay, we increase a iron core. So in place of air, now what we have? We have a magnetic substance. Suppose in the previous section, what we had here, what we had in between of this wire, air. So in air, of course, the strength will be less. Now to increase the strength, what we have done, we have inserted a iron core. Okay, iron core. Now here in this condition, the strength will increase further. Okay, this is my soft iron core. Okay, now again it is connected with battery. Okay, now when it is connected with battery, it will produce, the current will flow and it will produce magnetism. Here, if the same number of turn and same power source is applied and same copper wire is applied, but as we have just inserted a soft iron core, the magnetism of this circuit is more than this circuit. Okay, just introducing a soft iron core increases the magnetic field strength. Okay, and all the conditions that we have studied here will be applicable here also. Okay, we have done this experiment in our class 6 or 7, that taking the iron nail and making number of turns of copper wire and just connecting with the battery, so it will produce a magnetic field and magnetism, and it attracts the iron nails or pins. Okay, this iron core this iron core plays a vital role for increasing the strength of magnetic field. Okay, now, so we have discussed, now we will move further. So the next topic was, our next topic was force in a current carrying conductor. Okay, so in the last few minutes we have discussed what, when we had when we had when we had a current carrying conductor in a straight wire, it was the magnetic field was produced. Similarly, here also a field was produced. Okay, here also magnetic field was produced. Okay, now, so when magnetic field is produced, what happens? I will write one statement. Okay, golden statement. Okay, when magnetic field is produced, it also produce a force. How? So talking about electromagnet, what happens when the circuit was closed? When the circuit was closed, so it was producing magnetic field. That magnetic field was attracting the iron nails with some force. So a force was produced, a force was generated. Okay, so next we are going to study about force in a current carrying conductor. Okay, conductor. Now here one condition is what? One minimum requirement is we will be using one pair of magnet. Okay, one will be permanent magnet and one will be temporary magnet. Just I will explain one more thing over here. Okay, so if a magnet is kept here, okay, if a magnet is kept here with north and south, okay, now it has some magnetic field, when the other magnet will come, okay, with south or north, so what will happen? Either it will attract or it will repel. Okay, so with attraction or repulsion, with attraction or repulsion, there is a generation of force. Now this force was generated only when we had a pair of magnet. Okay, this force was generated only when we had a pair of magnet. So if I want to generate a force, I have to use two magnet. Okay, now so what we are going to do here is we'll be taking one stand. Okay, and I will be taking one, and this will be taken as coil. Okay, this is my coil. Okay, yeah, this is connected with battery. Okay, okay, now I will place, so it will produce an electromagnet. Now to generate a force, what we have to do, we have to introduce one more magnet over here. Okay, with a north and south. So what will happen? Either it will attract or it will repel. Either attraction force will be there or repulsion force will be there. Correct. So this is what happens when a pair of magnets are brought near. What happens? We have a generation of force. Now we have to know what is this direction of force. Okay, what is this direction of force? So we know direction of current, we know direction of current. Okay, we know direction of of magnetic field. Okay, now we have to calculate that, we have to find direction of force. Okay, we have to find direction of force. So that to know the direction of force, we apply Fleming left hand rule. Okay, left hand rule. Now, so for left hand rule, what we do, we take thumb, okay, forefinger and middle finger in such a way that they all are perpendicular to each other. Okay, they all are at 90 degree. They all are at 90 degree in this way. Okay, now the forefinger, this is my forefinger. So it start with f, f for field. Okay, f for field. Now we have our middle finger, or can we say it is as a center finger? Center finger. Okay. So center means C for current. So we know direction of magnetic field and we know the direction of current. Now align these two finger in such a way that the above circuit will be इन दोनों फिंगर को इस तरह से अलाइन करो ताकि जो हमारा रहे ना कि करंट हमारा किस डायरेक्शन में फ्लो कर रहा है, इस डायरेक्शन में फ्लो कर रहा है तो सेंटर फिंगर को उस डायरेक्शन में फ्लो करो। ठीक है, सेंटर फिंगर को ऊपर रखो। ठीक है, नाउ हमारा जो फोर्स है वो किधर है, फोर्स नॉर्थ टू साउथ होगा, तो नॉर्थ टू साउथ हमारा के डायरेक्शन में हमारा फोर फिंगर को अलाइन करो। तो जो हमारा जिधर हमारा ये फोर थंब डिनोट रहेगा ना, जिधर हमारा थंब सपोज ऊपर आया तो हमारा जो कंडक्टर है, जो हमारा यहाँ पे सॉरी जो हमारा यहाँ पे ये कंडक्टर है, जो हमारा इलेक्ट्रोमैग्नेट है, जिध वो उधर मूव करेगा। ओके, ठीक है। जैसे अगर हमारा फील्ड का डायरेक्शन इधर है और करंट का डायरेक्शन इधर है, तो हमारा जो फोर्स होगा ना, फोर्स वो हमारा ऊपर होगा, ऊपर की ओर। जैसे इसको इस तरह से समझो, हमारा जो फील्ड है इधर है, मतलब अगर ये हम अपना बोर्ड मानते हैं, ब्लैक बोर्ड मानते हैं या फिर व्हाइट बोर्ड मानते हैं, तो ये हमारा है नॉर्थ, ये हमारा है साउथ। ओके, जो ये है, जो ये वाला है, ये क्या है हमारा, ये हमारा बोर्ड के बाहर आ रहा है। ठीक है, बोर्ड के बाहर आ रहा है, ये हमारा डायरेक्शन ऑफ करंट है। ओके, नाउ जो हमारा थंब हुआ, थंब किधर डिनोट कर रहा है, ऊपर की तरफ, मतलब बॉटम टू टॉप, बॉटम टू टॉप। तो ये जो हमारा शो किया ना थंब, ये हमारा हुआ डायरेक्शन ऑफ फोर्स। ओके, नाउ अगर हम लोग जस्ट चेंज करते हैं, चेंज क्या करेंगे, अभी हम लोग नहीं, अभी करना है कि नहीं, हम उधर क्यों ले, हम इधर लेंगे, नॉर्थ ये है, साउथ ये है, तो नॉर्थ एंड साउथ ये है। ओके, और करंट सपोज मेरा इधर जा रहा है, बाहर आ रहा है। ठीक है, तो नॉर्थ एंड साउथ। ओके, करंट हमारा किधर जा रहा है, बाहर की तरफ आ रहा है, तो हमारा जो डायरेक्शन ऑफ फोर्स होगा ना वो डाउनवर्ड होगा। ओके, जस्ट अलाइन योर left hand and first three finger in such a way that this two will be giving you the current and field. So the third finger will automatically give you the direction of force. Okay, will give you the direction of force. Now here one more thing, if we will, so we have direction of current, we have direction of magnetic field. Okay, okay, and we have already discussed about what, number of turn, then voltage source, okay, presence of soft iron core, okay, and radius। okay, तो ये चार चीज हम लोग डिस्कस किए थे जिसपे स्ट्रेंथ ऑफ मैग्नेटिक फील्ड डिपेंड करता है। ये जो दोनों है, अगर हम इन दोनों में से किसी एक को चेंज करेंगे ना, तो हमारा डायरेक्शन ऑफ फोर्स भी चेंज होगा। ठीक है, जैसे हम सपोज करंट का डायरेक्शन को चेंज कर दिए, तो हमारा पहले सपोज ऊपर जा रहा था तो अभी नीचे आएगा। अगर हम मैग्नेटिक फील्ड के डायरेक्शन को चेंज कर दिए, तो सपोज पहले ऊपर जा रहा था तो अभी नीचे आएगा, नीचे मूव करेगा, फोर्स नीचे की तरफ रहेगा, मतलब मूवमेंट, हमारा जो कॉइल जो सस्पेंडेड है वो नीचे मूव करेगा। अगर हम दोनों को चेंज कर दिए तो हमारा डायरेक्शन पहले अगर ऊपर था तो अभी भी ऊपर ही रहेगा। ओके, तो इन दिस वे दिस force in a current carrying conductor is connected. Okay, this is very good concept. Okay, and it is very important to understand. We use this concept for making many things like speaker or motor, electric motor, or everything works on this principle, फ्लेमिंग लेफ्ट हैंड रूल. ओके, सो आज के लिए बस इतना ही. मिलेंगे अगले वीडियो में एक और कॉन्सेप्ट को लेकर. तब तक के लिए नमस्कार.